Hello and welcome back. This is a continuation of lesson 3 where we were discussing the transformations of quadratic relations of the form y equals x squared. So as we've mentioned, y equals x squared is the equation of the basic parabola, and the transformations are described by the equation y equals a x minus h squared plus k. We call this a vertex form of the parabola because it tells us what the coordinates of the vertex are. And just recall that the coordinates of the vertex are at h and k, point with coordinates h and k. And it also tells us about the shape of the parabola, which is described by the coefficient a. Okay, so we're going to take a look at these three examples and describe all the features as indicated and graph them. So the first equation is y equals negative 3x minus 1 squared plus 7. So we'll say that the coordinate h is 1 and k is 7. So we'll say 1, 7 is the coordinates of the vertex. In the next equation, your h value will be negative 1. The k value is positive 1. Okay, just to explain one more time to make sure. So when you have a minus, your h is positive because the minus you see in the equation is a minus in the general form in here, okay? So that you are subtracting a positive that makes h positive. Here, you see a positive because you are subtracting a negative value of h. That's why you see a positive. Two negatives will make a positive. In the next equation, we do not see h, but we can make it visible by rewriting the equivalent form of it. So we can either write minus or plus. So I'll keep it minus to be consistent with the general form of the equation. And we have negative x minus 0 squared plus 6. So the coordinates of the vertex are at 0, 6. Now, about the direction of opening, we'll say that a parabola can either open up or down. So a parabola opens up when a is positive, it opens down when a is negative. So in the first equation, we have the value of a negative. So that will open down. In the next one, a is positive, it will open up. Here, negative 1, it will open down. So let's write this down. So negative coefficient a, parabola opens down. Positive coefficient a, parabola opens up. Negative, that means down. So it doesn't matter what the value of a is. All that matters is the sign of it, whether it's positive or negative. The next thing we'll talk about is the equation of the axis of symmetry. So as we know, the parabolas are symmetrical shapes, and the axis of symmetry is the line that divides it into two equal parts. It's a vertical line, and it passes through the vertex. Since it is a vertical line, the equation will be in the form x equals something, because that's the form of any quadratic equation. Any vertical line. And x equals, in this case, the coefficient h, because that would be the x coordinate at the vertex. So in this case, we'll have h equals 1. So the equation of axis of symmetry is x equals 1. Next, h equals negative 1. So the equation of axis of symmetry is x equals negative 1. In the last one, the value of h is 0, which will make the equation of the axis of symmetry x equals 0. So next we will talk about max or minimum function. Now, a quadratic relation. So remember, a maximum occurs when a parabola has a highest point, and a minimum will occur when a parabola has a lowest point. So, like this. Now recall what determines max or min, or what determines the parabola having a highest or lowest point. So the coefficient a. So the coefficient a negative will make the parabola have a max. So if the coefficient a is positive, means that the graph will have a minimum. So we're going to say in the first case a is negative. So that means that the parabola will have a maximum. In the next equation, a is positive 2. So that means the parabola will open up, so it will have a minimum. In the last one, a is negative, so it will open down, so the parabola will have a maximum. Now, since we're here, let's determine what the value, the actual value of min or max is. Now, remember that how high or how low a parabola is on the graph will be determined by the y-coordinate at the vertex, because the vertex is what marks the max or the min. And on the other hand, the y-coordinate or the vertical coordinate determines how high or how low a point can go. That rhymes too, huh? So we're going to say that maximum in this case will be the coefficient k. So coefficient k is 7. That makes the maximum value 7. The next graph has a minimum, and the minimum will happen at the vertex. It will be determined by the y-coordinate at the vertex, which tells us how high or low the parabola can go. And we're making verses now, rhyming verses. So here we are, and we have 1, so minimum will be 1. And the last one, minimum will be 6, because that's a k value of it, right? Okay, so we've forgotten the x in there. 6. Now we're going to talk about the stretch of the parabola. Now, the stretch of the graph is again determined by the coefficient a, as we mentioned before. Now, if coefficient a is a number bigger than 1, such as even 1.1 or 1.5 or 2, 100, so it will be a vertical expansion, we say. If it is less than 1, but bigger than negative 1, so a number such as negative half, negative third, 1/2, 1/3, so then it will be a vertical compression, so the stretch will be in a compression kind of form. So in the first case, we have a negative 3. That will make the stretch vertical, so expansion. It will make the stretch an expansion. So we're going to say that the parabola will be taller, to use simpler language. And in the next case, in the next equation, when a equals 2, the parabola will get taller again, because the y values will get 2 times bigger compared to the basic parabola y equals x squared right here. And the last one actually has a coefficient -1. A coefficient of -1 tells us that the parabola has not changed shape, so we'll write here same, and that's clear enough. Now the last, which is a very important actually concept, is determining the range of the quadratic relation. Remember that for the domain x is any real number, we don't have to think at all about it, unless we are in particular application questions, but we'll specify it when we get there. Now the range can be limited due to the fact that the parabola can have a max or a min, so y cannot be any real number, so it can reach a maximum and everything has to be below the maximum, or it can have a minimum and everything else has to be above the minimum, so higher than that. When a parabola has a maximum, all the points will be less, the rest of the points will be less than the maximum. The way I write the range is this. I always say that y has to be any real number, and that describes the fact that the y values are real numbers, so they're not specific natural or whole numbers or certain integers, right? So it can be any real number, so it can be a radical number, it can be any real number that exists out there. Now, such that we're going to say, though, because we have some conditions or limitations to the y values, that the y values satisfy the condition that they're bigger than the minimum or less than the maximum. So let's stop there and think again. If a parabola has a maximum, that means that will be the highest point. So where would the rest of the point be? Below it. That means less than or equal to the maximum. If a parabola has a minimum, like in the second equation, a minimum, where would the rest of the points be? Well, if it has a minimum, the rest of the points have to be above the minimum. So we say bigger than or equal to the minimum. And if a parabola has a maximum, again, like in the last example, then we'll say that the parabola or the range will be less than or equal to the highest point, which is at 6. And I will close the squiggly brackets in here, or the braces we call them. And now we're going to start graphing. Now when we graph the parabolas, we want to compare with the basic parabola, and I pre-drew the basic parabola y equals x squared in each graph. And we're going to get started with the first equation. Now we only need two things to graph the equation of a quadratic relation. The number one thing will be the vertex. And for the first equation, the vertex is 1, 7. The number two thing would be the step pattern. For short, I write SP. And the step pattern is always, remember, 1A, 3A, 5A, and you can continue on with the rest of the odd numbers in order. So in our case, because A is -3, it will be -3, -9, -15. Okay? And this is H and K, we said. So I'm going to get started with the vertex, which is at 1 and 7. Sorry. And from the vertex, I will apply the step pattern, which is -3, -9, -15. So that means that if I move over 1, I have to move down 3, over 1, and then I have to move down 9. So let's do this. So over 1, down 3, over 1, and then down 9. I don't have room to apply the next step, so I leave it there. And I will apply the step pattern on the other side. So over 1 to the left, down 3. Over 1 to the left again, and then down 9. And so on and so forth. Okay, so that would be the graph. And try to compare it with the graph of the basic parabola, right? So it is a parabolic shape, but it is taller and it is translated and turned upside down. The next graph will have the vertex at -1, 1, and by all means, if you want to try graphing this on your own, just stop the video and get graphing. It's more fun when you answer the questions on your own. It's more accomplishing. So in the next equation, we have the vertex at -1, 1. So I will mark the vertex first. So x -1, y +1, right here. And then from here, I will apply the step pattern, which is 1A, 3A, and then 5A. And A is 2, so that means 1 times 2, 3 times 2, 5 times 2. From the vertex, I will go over 1, up 2, over 1, up 6, and so on. So here we go, over 1, up 2, over 1, up 6. I don't have more room to go a little higher, but I think it's enough for us to kind of see what the shape of the parabola is. And we're done. If you were wondering where the axis of symmetry is, then look at it this way. So the middle of the parabola is at the vertex, and since it is at the vertex, then we draw the vertical line that crosses the vertex. You see how the parabola will cross -1, which is the x at the vertex. That's why we say the equation of the axis of symmetry, I'll add this one here just for this example, is x equals -1. Okay? And this parabola is taller than the basic shape. Now the next graph is negative x, y minus 0 squared plus 6. The vertex is at 0, 6. Let's choose a fun color here. So I will go with orange. And x0, y6 will be right on the y-axis. And from here, we'll apply the step pattern. So 0, 6 is the vertex. And the step pattern here, because we have a coefficient of -1, is -1 times a, -1 times, 3 times a and 5 times a. So that would be -1, -3, -5. And from the vertex, we're going to go over 1, down 1, right? Just follow the pattern. Over 1, down 3. Over 1, down 5. And the same thing on the other side. Okay. And that would be the graph of the parabola. All right. So moving on, I just wanted to make a summary of everything that we've done so far. This is for you to complete. So again, stop the video and try to complete it on your own. Now remember that the coefficient a, or the parameter a, sometimes we use that fancy word, parameter, for coefficients. So the parameter a will cause a vertical stretch. Now, remember that in mathematics, a stretch can be an expansion or a compression, okay? So we're going to say that it will be a vertical expansion, and for short, I like to use this acronym, vertical expansion, and I would write taller. When does that happen? When the a values are bigger than 1 or less than -1. So you can imagine it this way. If you had a number line that represents the values of a, and here we have a -1, a +1, and here is 0, but a can never be 0, okay? So for the a values bigger than 1, for all these numbers here, and for a values less than -1, so for all these values here, the parabola will be stretched vertically or expanded vertically, we should say, to be more precise. And a vertical compression makes the parabola shorter, and a vertical compression will occur when the values of a are in between -1 and 1. So that's a vertical compression, okay? And those are expansions. And obviously we know that when a is negative, then the parabola will open down. So if we are going this way, all right, it opens down. So the parabola will have a maximum. And here it will open up. Now the parameter h will cause a horizontal translation. And what that means is that the parabola can move to the left or to the right. For short, I like to write horizontal translation using the acronyms HT, okay? And if H is positive, it will move to the right. So if you have y equals x minus 2 squared, that means 2 units to the right. If you have y equals x plus 2 squared, that means 2 units to the left. Okay? I'm going to make this number 2 a little pretty, a little bit more pretty because it's kind of confusing. Okay? So the parameter k will cause a vertical translation. And for short, well, you guessed it, I use the acronym VT here. And again, we're going to say that k positive will move the parabola up, k negative will move it down, okay? So the next questions that we are going to look at are some I would say them kind of reverse problems. So we are given the graphs in here. We need to write the equations of each parabola. So let's get started with the first one. Remember how we said that to graph a parabola, we need a vertex and a step pattern. Now, similar to this, to find the equation of the parabola, we need to identify the vertex and the step pattern. So the way we do it is this. First, identify the vertex. So the vertex will be, in this case, the vertex will be at x equals 0 and y equals -7. So this will be the h and this will be the k in the equation. The next thing we want to look at is the step pattern. And for the step pattern, we start from the vertex and we move over 1 unit. Okay? And we see if we want to get to the next point, how far do we have to go? So it looks like we're going over 1, up 1, over 1, up 3, over 1, and then up 5. So it seems that we are following the step pattern 1, 3, 5 in here. Sorry. So that means that coefficient A is equal to 1. So the equation of this parabola would be y equals, I'm going to write the coefficient 1. We don't really have to, but I just want to make a point about what I found in here, plus -7, sorry. And if you want to write it even in better form, so that would be x squared -7, and that would be it. Okay, right here. In the next example here, we have the vertex right at this point, which is 0 and 5. And with this, we know what the h and the k values are. So we'll say h is 0 and k is 5. So we have x in here. So with an h of 0, we're subtracting 0, and with a k of 5, we're adding a 5 in here at the end. Now we have to determine the step pattern. So I am going to go from the vertex over 1. Next point that I hit is 1 unit further down. Over 1, further down 3. Over 1, further down 5. So since we're going down, following the same pattern 1, 3, 5, sorry about that, then we're going to say that a is -1. So we're going to write a negative sign in here in front of the equation, and we have squared in here. In a more simplified form, we can simply write y equals -x squared plus 5. This will be the equation of the second parabola. In the last equation here, we have a vertex located right at, let's go orange again, x -3, y -4. So we have the h of -3 and a k of -4. And let's study the step pattern here. So we're going from the vertex over 1, down 1, over 1, down 3. So it seems that a is -1. So the equation will be y equals -1, x minus -3 squared plus k, which is plus -4 here. So that will make it -1 x plus 3 squared minus 4. This would be the equation of the last parabola. Now, in the next group of questions, we are given the description of the transformations of a parabola, and we need to write the equation from it. And this is as much of a variety that you're going to get in your evaluations or in your tests, right, when it comes to describing parabolas and quadratic relations. So we need to write the equation of a parabola congruent to y equals x squared. Now remember, the word congruent stands for the word same as in shape, okay? So we're going to say this is same as shape, or in other words, we're going to say that the coefficient a will stay 1, because that's what shapes the parabola. It opens up, which means that a will be a positive number, And the vertex is at 1, 4, which makes h1 and k4. So we're going to say the equation is y equals 1, x minus 1 squared plus 4. The next question says that the parabola is congruent to y equals 5x squared. So what that tells us is that the shape of the parabola will be the same as the shape, which means the a value will be 5. Now, the parabola has a minimum. A minimum means that it opens up. And when a parabola opens up, that means that a is positive. So we're going to say that a is positive 5. And h is 3, k is 0. So the equation will be y equals 5, x minus 3 squared plus nothing. So you don't have to write anything in here, okay? Sorry about this, I have to write 4. I don't know why I did that. Congruent to y equals 2x squared, maximum at -1, 7. Again, congruent to 2x squared means that the parabola will have a value of 2. The fact that it has a maximum means that a is negative, so we're going to give this a negative sign. Maximum is at -1, 7, so we have h and k given. So the equation will be y equals -2, x minus -1, which makes it plus 1, and then squared plus 7. The last one is a little bit more interesting. So we have congruent to y equals 4x squared, so that means a is 4. It has a maximum, so we're going to say a is negative, so -4. The maximum is located on the x-axis. Now, this is a different kind of story, so let's look into this. So if the maximum is on the x-axis, I'm going to try to illustrate it in here. These are very ugly axes that I just drew. Let me make it nicer here. Okay. So if the maximum is on the x-axis, that means the maximum must be on anywhere here on the x-axis. And if it is a maximum, it's opening down. Can you tell me the coordinates, or think about what the coordinates of this point here will be? So you will have some x value, right? But the y value you will know for sure. The y value will be 0. So with this piece of information, they are telling us that the y value at the vertex, or the coefficient k, will equal 0. Now, the axis of symmetry is x equals -2. Now, remember that the equation of the axis of symmetry is always x equals h. So with this piece of information here, they are trying to tell us what the h coefficient equals, okay? So now we're ready to put everything into the equation. So we have everything. So we have a -4, x minus -2, so that makes it minus -2, right? So +2 squared, and then plus 0 in here because the k, it will be 0. Well, I hope that this consolidated your understanding of the transformations of the parabola, and I hope this all made sense. Okay,